The MV OOCL Hong Kong, the largest container vessel ever built, capable of carrying over 21,000 containers. Hi. In this episode of Commodity Brief, we're going to be looking at the largest container vessel ever built. This is the MV OOCL Hong Kong. Now, if we're looking at a vessel like this, it's important to get an idea of the scale of the vessel. So this is the vessel compared to a number of quite well-known landmarks in London, and we can see that purely the length of the vessel is much larger than some of the largest buildings in London. Now, if we're looking at container ships, it's also important to have a talk about the progression and the size of these container vessels. Containers themselves didn't really exist before the 1960s, but since then they've been building vessels that can carry more and more containers. And we can see we started off in the 1960s. At first dedicated container vessel could carry about 1,500 containers. These are 20-foot equivalent units, and so these are your standard containers that we're very used to seeing in many places. Then they progressed quite quickly until we got to about 2003. Here we're up to about 9,000 containers, and this was the right size to fit through the Panama Canal. But the size kept on increasing very rapidly until we are where we are today, above 21,000 containers with the OOCL Hong Kong. Now, just to give you some ideas of the actual scale of it, because when we see a vessel like this, it's difficult to really judge scale. And so, first of all, looking at some of the figures. We have the width of the vessel, the breadth, 58 meters wide. So this is just the width from one side to the other. Then we have the draft of the vessel, 14.5 meters. Just to give you an idea, if you think the average size of a floor in a building is about 2.5 meters, if you're standing on the 6th floor of a building and this vessel was to sail down the road in front of you, you wouldn't be looking at the chimney, you wouldn't be looking at the bridge, you wouldn't be looking at the waterline, you would be looking right here, right down at the bottom. And so even below water, there's a huge amount. Then in terms of the carrying capacity, we're talking 21,413 containers, and obviously we'll have a mix of a number of different containers that we'll look at in the container episode. And otherwise we have the length of the vessel, 400 meters long. Now, we always seem to go back to the world of football, but this is essentially 4 football pitches long, and it is very large. Now, the consumption and the speed is also quite impressive, because this vessel sails at around 19 knots, and 19 knots is about 35 kilometers an hour, just to have an idea in terms of something we can connect with. And 19 knots. A typical cargo vessel or a tanker will typically sail around 12 or 13 knots. So this is very quickly for an ocean-going vessel. And when it's sailing at about 19 knots, it's using up about 180 metric tons of fuel per day. And so if you imagine this vessel lives its life sailing from Asia over to Western Europe, and that voyage might take 20-25 days, every single one of those days it uses up 170 metric tons of fuel. And also important is the price. So here we're looking at $950 million for this vessel. Now, in terms of vessels like this, it's also interesting to have a look at what we can fit on board of a vessel. So in terms of a couple of things that we see in every day, first of all, refrigerators. You can fit about 1 million refrigerators on board this vessel in the containers. Mattresses, looking at about 4 million mattresses. Flat screens. We see a lot of flat screens being transported by container from Asia to Western Europe. About 8.5 million flat screens on board of this vessel. And bananas. Bananas are often transported in containers. We're talking about 1 billion bananas on board of this vessel. So the scale is really difficult to get our heads around and to understand how massive it truly is. Now, if we're going to be looking at the vessel like this, then we also have to look at the risks, because On one side, we have these fantastic economies of scale. As the size goes up, the unit cost reduces dramatically. And so if we take a vessel such as this, then yes, we can carry 21,000 containers on board. We're using up 170 metric tons of fuel per day, and we have maybe 22 crew members on board. Now, if you have a vessel that can carry 2,000 containers, so 10% of that, then still you have about 20 crew members on board. In terms of fuel, you'll probably be using about 40 or 45 tons of fuel a day. And so the unit cost as you increase the number of containers reduces significantly. And so we have this massive advantage of the economies of scale. But whenever we're looking at these, we need to look at the risks as well. And so first of all, we have a problem of congestion. These vessels are getting larger and larger. They are taking more and more time for their loading and discharging operations. And so we end up with the ports being quite congested because there are very few berths which are available for this size of vessel. Now, we also have consolidation of lines. And it's something that when we look at the number of shipping lines, the number of shipping lines that can afford these types of vessels are actually very few. And today we have 45% of the world's container traffic is consolidated between 3 container lines, between Maersk, MSC and CMA CGM. Now so the consolidation of lines, while it can be good for economies of scale, it can be good for increasing efficiencies, the problem is that we don't know what the end result will be. And we don't know whether we'll simply end up in a situation 5-10 years down the line where we have very, very limited choice and then the prices end up getting pushed up again. So we need to be careful of that. We also have barriers to entry. A vessel like this costing $950 million to build. It's very, very difficult to enter into this market, to become a player in the market. And we also have large vessels being pushed onto smaller routes. This is a problem that's not obvious at first, but basically the way the container world works is you have these very, very large vessels doing the hub routes, so from hub to hub, and then you have a slightly smaller vessel doing the smaller routes, and then smaller vessels going down doing the smaller routes. Now the problem is, as soon as a big vessel like this comes in, then the vessel that was the biggest doing the hub routes before gets pushed down, the next vessel gets pushed down to the next route, gets pushed down, and we end up in a situation like you have in Cotonou, in Benin in West Africa, and basically they have one long berth, it's 1 kilometre long. And this berth, if you have vessels of 200 metres long, then you can fit 5 vessels at the berth at any one time. The problem is that the types of container vessels which are now serving that market are larger than 200 metres, and so this one port has gone from having 5 berths to only 4 available berths. And so this is an issue that is impacting on some of these smaller ports. And also, these vessels are too large for the canals, too large for the Panama Canal, too large for the Suez Canal, too large for the Kiel Canal. And so then we have to sail further to get to where we're trying to get to. So while it's good to focus on the positive sides of these vessels getting larger and larger, there also are a number of slightly less positive or even negative sides that we also need to focus on. So we have this vessel, the largest container vessel ever built, 21,000 containers on board. And the only thing that we don't know is where this is going to go, whether they're going to keep making bigger and bigger and bigger vessels, and at what point it's going to stop. So this brings us to the end of looking at the largest container vessel ever built. And please click back for other episodes in the Commodity Brief series. Thank you very much.